Alright guys, so we're going to start talking about circles in chapter 2. So there's a few definitions that I want to go over with you guys, and you're going to have these slides right in front of in your packet. So let's take a look at this slide that looks similar to what you're seeing on my screen right now. It says 2.1 circles, and then it has 3 smaller circles to the left hand side. That's what we're going to look at first. So here you've got your radius. All right. Radius just means that we're starting from the inside of the circle and then going out to one of the points on the circle. So there's infinitely many radii, right? That's a plural for radius. So that's important to know that it starts in the middle, or center, we're going to say. And has endpoint on the circle. Okay, so you guys should have written down starts in the center and has endpoint on the circle. Okay, so that's a radius. So it starts in the middle, and when you're labeling, you always start with the middle point and then go out. So in this case, we're going to look at, in a few minutes, this circle to the right of us to see if we can name a radius, a diameter, and a chord. So the next thing that we're going to talk about is a diameter. Diameters are a line that is in our circle who has endpoints. The 2 endpoints are on the circle and it goes through the center of my circle. Okay, so it's actually, we're going to call it a chord whose endpoints are on the circle. And at any point you guys can pause this video so you can make sure that you have this written down correctly for yourself. So diameter is a chord whose endpoints are on the circle. Alright. Then we've got a chord. And a chord just is a segment in a circle whose endpoints are on the circle. So we can have all different types of chords, and we'll talk further about those in the coming section. Okay, so a chord is a segment in a circle whose endpoints are on the circle. So like in this case, if we just drew 2 dots someplace on the circle, any points, and then just drew the line through it, that's a chord. Now I could take and say, well, I want to draw a chord from this point that I just drew to the next point. Okay, and I actually can just draw another chord. Okay, so the chords can intersect, and again we'll look at different types of chords. So the one connection that I really want you guys to make at this point is that the most common chord that we have, alright, is a diameter. Okay, so the diameter is your special chord that we know. Okay. So we're going to look here. Okay, now we've got to figure out which segments in here, so which portions of a line kind of fall in these categories of radius, diameter, or chord. And the first thing we're going to look at is, let's say, radius. Okay, so I'm looking here at my circle, and I'm looking at my center, and any point that starts in the center and has an endpoint on the circle is a radius. So HE is a radius. Okay, there are 2 more. Can you guys see the 2 more? And you're probably all shouting out the answers at this point. So HD is another one. Okay, and then the last one, HG. And I'm just putting that little line above it, just signifying that's a segment. It's part of a line. So anytime we have a radius, it starts in the center and has an endpoint on the circle. Okay. next one we're going to look at, we have to pick out our diameter. So take a look at this circle. Diameter is a chord, so a segment, who has its endpoints someplace on the circle and then goes through the center of that particular circle. Alright, so whoever says GE is correct. That is a diameter in this circle. Okay. Last one. Now, chord is a segment who has an endpoint on the circle. So looking at this particular figure, alright, G to E, isn't that a diameter but also chord? And then our last one's going to be what? G to F. Okay. At this point, if you want to stop and pause and ask any questions, you can go ahead. Okay, so we're ready to move on to the concept and connection of a diameter and a radius. So we have to know, well, what is the relationship between the radius and the diameter? All right. So I'm going to write down this formula for you guys. The radius is equal to 1/2 the diameter, or the diameter is equal to the twice the radius. Okay? So it's a half or double relationship depending on which you look at first. So if we look at this first question, it says, well, my diameter of this particular circle is 12. What is the radius? So I'm going to use, well, I want to figure out what the radius is. So what is half of 12? Right, it's going to be 6 in this case. Okay, so let's take a look at the next one. Okay, so if a circle has a radius of 5, how long is the diameter? Well, up here we just said, and I gave you that hint of D equals 2 times R. So if I plug in the 5 in for R, you're going to end up getting your diameter, which is 10. Okay. So at this point, we are going to review this concept, answer any questions that you guys might have, and then we're going to try some class practice. So if you need to, pause before we go over this class practice. Other than that, I'm going to give you guys a few minutes to look at this. So again, we'll just pause, see what questions you guys might have. Take a couple minutes. Alright, welcome back. Alright, so we're looking at the circle. Alright, so circle X, alright, and that signifies anytime you see a circle and then followed by a letter, that's another way to name the circle. You have to identify all the radii. Alright, so radius is a segment who starts in the middle and then goes to the end. So you should have XB, XC, XA, and that's it, right? Okay. A chord. What's a chord? Well, a chord is a segment whose endpoints are somewhere on the circle. So AC is one of them, and then ED. Now you could have written these as DE and CA, so if you have that, you're also correct. The radius, you always have to start with the center and go out. Okay. Identify all of diameters. So looking at this figure here, I'm only seeing one diameter because it's going through the center of our circle. So that's AC. Okay. Next one. Okay. It says that BX is equal to 3. So BX, so XB is my radius. So we need to know how long AC is. Well, if BX is 3, doesn't that make XC 3 as well as XA because they're all radii? So A to C is going to end up being 6. Right, we got a few more to go. Okay, so if AC is 16, so this whole thing, so let's just get rid of these 3's. So if AC is 16, so that whole thing 16. What is XC? That should be half, right? So you guys should have had 8. Right? Because the radius is half the diameter. Okay. Last one, it says, if BX is equal to 3, what can be said about the length of ED? So let's go back up here. BX, they say, is 3. What can be said about the length of ED? What do you guys think? Well, in this case, it's not a diameter, so it can't equal 6. And if that's the longest chord is a diameter, then ED has to be less than 6. So we can say that ED, so we'll say ED's length is less than 6 centimeters. Most likely longer than 3, but we can at least for sure say it's going to be less than 6. Okay, so at this point, you guys are ready to move on to some more practice on your own. If you have any questions, please make sure you ask, and I'll meet you back on one of these videos in the near future.